Good evening, everyone. Thank you very much for being here with us. We're very excited to welcome you for this special occasion because it is EPFL Xplore's 5th unveiling. So thank you very much for being here. So my name is Ugo Balducci. I'm the current president of the association. And as I said, we're very excited to show you what all the benevolence of this association have been working on for an entire year. And their work is amazing, I'll tell you. So first, before jumping too quick on the technical stuff, we're going to go in the past. So Xplore started in 2020 with a team of passionate students that wanted to take up a new challenge in space robotics. And they had decided they wanted to participate in an international competition called the European Rover Challenge. So in only 1 year, they gathered a team and built our first system, the rover Argos. And they did pretty good. And the following year, building upon their experience, they were able to improve their solution and develop Astra. And this rover achieved our highest competition place, finishing second at the European Rover Challenge. We then had Kirby, who at the time was also accompanied by a new mate for its journey, our first drone, Broccoli. And finally, last year, Onyx and Dragonfly, the drone, were developed. 2024 was also a year of drastic changes for the association with the creation of 2 new poles that broadened our perspectives. And so here we are now. The association is organized in 3 distinct poles that complement each other and enable a progressive learning experience for our members. The Xplore Challenge, our education pole, the European Rover Challenge, our international competition pole, and finally, the Xplore Research for advanced research projects in partnerships with industry and academics. Throughout these poles, we aim to bring together passionates, willing to build and learn together, who also have an interest in space exploration and rovers. Thanks to our initiatives, we trained the next generation of engineers to be proficient in real-world scenarios. They gain a true hands-on experience that forged their capacity to play a key role in the teams that they will integrate and be autonomous. And we see that this has already borne fruits. The experience they had at EPFL Xplore allowed many alumni to integrate top-tier companies and institutions for their internships, master theses, and jobs. And this trend does not only apply to space-related fields, but to a wide range of engineering domains, thanks to the diversity of our team. We have more than 120 students contributing each year, coming from 5 institutions with more than 12 different specializations represented, ranging from robotics to electronics through economics, just to name a few. But students might still wonder, okay, but maybe it's not for me. I don't have the particular skills or competence that are necessary. But that cannot be further from the truth, because we learn and grow together. And we have education initiatives. So let's dive in a little bit.
Hello. Thank you, Hugo, for the presentation, and hello, everyone, as well as welcome to some of our mini rovers. So, I am Tiffen, this is Zoe, and this is Noor, and we are the project manager of Xplore, the XRC, the Xplore Rover Challenge. Xplore Rover Challenge is the educational pole of Xplore. The goal is to provide a project where students can build a small rover from scratch, from chassis design to printed circuit boards, as well as the software to control their rover. We want to give them a hands-on experience of an engineering project, from design to constructions, early on in their studies. Our project does not require any previous knowledge, as most of our members coming in XRC are bachelor students. The project lasts 8 months and ends with a competition at the end of the year where our teams can challenge their rovers.
This year, there is 40 students divided in 9 teams. The teams are composed of a group of 4 to 5 students, each of them working on a specific part of their rover: the electronics, the mechanics, the software, and the project management. In addition to its educational purpose, one of the goals of XOC is also to train the future member of the competition pool. This year, 25% of the XOC alumni has joined different pools such as navigation, drone, structure, or handling device, and even the management, like us.
XRC is led by the project managers, and the teams are coached by Xplore members for technical support. The teams have different meetings during the year, first individually with the coaches and us to see their ideas. Then we organize a series of reviews and presentations with the ERC members to gather further knowledge. These presentations allows us to connect all the members of the association to see and share their ideas and knowledge. Last but not least, we also organize a series of workshops throughout the year, tailored for each type of team member. So these sessions provide the participants with the basic understanding they need for the challenge and help them get familiar with the different tools they will use, as each team will follow a specific path, a learning path adapted to their role, whether it's in mechanics, electronics, software development, or project management.
The competition is then centered around 4 tasks: 2 are individual and 2 are collectives. We have an obstacle avoidance course that should be done autonomously by each rover. Then we have navigation tasks on different terrain, a manipulation task, and a race.
Teams are judged on the outcome of the competition task, but also on their presentation throughout the year, as soft skills are valuable as much as technical ones.
This year, the competition will be held the 24th of May at the Mets Hall, so if you'd like to support our teams, we'd love to see you there.
Joining our pool will give you a first-hand experience and knowledge in robotics. But at EPFL Xplore, we also have some more innovative and challenging projects in our research division. And to present the first project, I would like to invite Camille Lanois, to the team leader of the AI team, to the stage.
Thank you, Tiffen. Thank you, Zoe and Noor. I am very proud to present you the work of the AI team. Our goal is to improve the rover performance, but also push innovation further with cutting-edge AI solutions. That said, I present you our idea of the smart rover. This year's rover is connected, focused, and self-taught. To make that possible, we started by improving how it sees and moves through smarter navigation systems. Navigation is a key area where we apply AI. For path planning, we have used reinforcement learning to train the rover to make navigation decisions based on its surroundings. It now adapts to complex and unknown terrains. This system was already functional in 2D and is now extended to 3D simulations with realistic obstacle conditions. And speaking of obstacles, this is exactly what our second project is about. During the last competitions, we have noticed that humans coming too close to the rover were hindering its performance. To solve this, we have trained a computer vision algorithm, or model actually, to detect human figures, as shown in the top video, that you can see the human figures are highlighted, and then remove them from the LiDAR data, results being shown in the bottom video. And this has been achieved with a 78% accuracy. But sometimes you still need to guide the rover yourself. So what if to do so, you can simply talk to it? That is exactly what our next project is about. With the Human Rover Voice Communication project, you can now simply communicate to the rover with natural language, either directly with a mic that will be integrated to a structure, or with a mobile app that is ideal when you're further away or there is a lot of noise. And if you don't feel like talking, you can simply text it. The mobile app also supports written instructions that you can send to the rover and always in natural language. This was made possible thanks to our collaboration with Elka. This is it for the projects on the rover, but not for the AI team. There is more happening behind the scenes. We have worked hard to improve the team productivity with our custom chatbot that helps members access information quickly. Like this, members can access data that comes from our internal tools, including Notion, Slack, and Google Drive, thanks to retrieval augmented generation. This allows new and existing members to find documentation, procedures, and resources without having to ask around or search manually. Let's take a look at a demo video. As you can see, I'm asking the chatbot when is the unveiling taking place. And it's now able to answer correctly because it has found the data in the Google Drive. The unveiling is happening right now in the Rolex Learning Center. You may remember this chatbot from last year, but after a year of hard work, of refinement of the chatbot structure, but also the data quality, because the two goes hand in hand, I am now excited to announce that a live beta is out. So I invite you all to scan this QR code and test it out. This will help us tremendously in our last testing iterations of the chatbot. Because it's still in testing stage, if you feel like an answer is wrong, do not hesitate to report it and actually write what it was supposed to say. This is it for the AI world, and now it's time for some groundbreaking hardware innovation. I will leave the floor to Theo Eng and the Legged Robot project.
Thank you, Camille. Hi, everyone. My name is Theo Eng, and I'm the current team lead of the Legged Robot project. This project is fairly new to Xplore and started only less than 2 years ago. The original goal of the team was to build a large 12 degrees of freedom quadruped robot, and to start on such an ambitious journey. It was decided to build this robot one leg at a time, starting from the design of our very own custom actuators. But regardless of the final goal and final product build, the broader goal of this team was to develop custom and state-of-the-art hardware by experienced students, gain knowledge and technologies, and hopefully implement some of it into the current rover. Now, as I said, our current mission is to build a leg, so let me explain a bit more what I mean by that. The typical leg of a quadruped robot with 12 degrees of freedom is composed of 3 main actuators. 1 linear for the knee joint, and 2 rotary actuators for the hip pitch and hip abduction joint. So now the next obvious question is, what actually is a rotary actuator? Well, it's composed of 3 main parts. 1 custom brushless DC motor driver with an integrated encoder, 1 large frameless hollow brushless motor, and 1 reduction system, in our case, a single-stage planetary gearbox. You bring everything together in 1 single custom enclosure, and you get a rotary actuator. So this year we focused on improving our design, and we built a second iteration. And now I'm really happy to introduce to you Actuator 2.0. This new iteration, we greatly reduced assembly and manufacturing complexity. We integrated an active cooling system and proper cable management. We also did everything while reducing the actuator thickness by 50 millimeter and keeping the same peak torque of 72 Newton meters. But then you might ask, what is a new actuator without a new leg? So that's exactly what we did, and we built a new leg. So say hello to leg 2.0, a ball screw leg entirely machined in-house by students, 50% thinner than the previous iteration and 700 grams lighter. But most importantly, it is now pretty much backlash-free. And after building this new leg and this new actuator, the next challenge was to connect them together. And this is when a very talented student came up with an interesting idea, a quick attach system. And this clever system is actually inspired from some 3D printers. And it allows effortless connection of the leg to the hip actuator by just plugging it in. You don't need any screws nor any tools. You just plug the leg, the power cables, data cables, and that's it. You're good to go in just a few seconds. And this system provides a strong and rigid connection, and like the rest of the leg, is entirely manufacturable in-house by us with traditional machining techniques. But that's not all. We also worked hard to develop the final piece of the puzzle to have a fully custom power system going for all batteries to our motor drivers. And now I'm happy to present you Batman, our new battery manager. And it is designed to allow safe discharging, charging, and storage condition of our batteries, and is powerful enough to accept up to 10 cells batteries for power-hungry leg robot, but is also small enough to fit on the smallest battery packs. But at Xplore, we're not only about building cool, fancy actuators and fancy tech, but also a sustainable one. And this is why I would like to welcome on the stage Giovanni Aragna, who will tell you more about our plastic recycling initiative. Thank you.
Thank you, Theo. Now, let's finish this research poll with the Recycling Plastic project. This project was born from the idea that we could reuse 3D printed parts that were obsolete to create new filament. Its objectives were to be low cost, open source, and yet produce high quality filament. The machine works as follows. You have first a 3D printed part that you shred. After that, you dry it, and you put it inside an extruder. The melted filament that goes out is cooled by water cooling, and the diameter of the filament is measured in the end. After that, you have the new filament that is pulled and spooled. This year, we aimed at implementing a closed loop between the diameter sensor and the speed of the spooling to better control its diameter. Uniformity of that is required by the printers. We improved also the spooler and wrote the software to control it. Additionally, a dryer is being made. It aims to control the temperature and humidity and adapt its heating accordingly. It must limit energy losses and should be able to pour the material directly into the extruder, or it can store it. The setup must withstand 100 degrees. Here is the first prototype. The air comes into the fan. It is heated and goes into a chamber where there is also the material. There is a mixture that ensures uniformity of the drying, and at the bottom you have a valve that permits to release continuously the material. This project was thought to last 2 years and should be finished by end of June this year. Now, you may ask what will be the next steps of our research poll. What do we want to do now? And during these last 2 years, this poll has let us explore new horizons, experiment new things, and more importantly, learn. Working alongside companies and speaking with experienced people from EPFL about new technologies are just 2 reasons why this poll is so important. To continue on this path, and because our association is also a space for innovation, we want to extend this poll to new ambitious projects, but with a closer look on space robotics. Instead of scattered initiatives, we're moving towards a unified and long-term research vision. We want to concentrate our efforts, bringing mechanical, electrical, and software teams together around concrete and application-driven challenges. Each project may stand alone, but they will all they will all contribute to a shared direction, pushing the boundaries of what's possible for robots in extreme environments such as space. And now, the moment that you all wait, the competition poll. Please welcome on stage Antoine Inari. It's amazing project manager that will lead the competition team this year.
Thank you so much, Giovanni, for such a presentation and such introduction as well. So, hello, everybody. My name is Antoine Henry, and I'm the project manager of the ERC division at EPFL Xplore for this year. So, some of you might be wondering, what is the ERC? The ERC, basically, it's a robotic competition. It's held annually, and it's held in Poland in either in August or in September. EPFL Xplore has taken part of such competition for the last 4 years, in which we have managed to obtain 3 podiums as well as 5 Excellency Awards. This year, more than 100 applicants have applied from 31 different countries across 5 continents. However, keep in mind that only the best teams will be allowed to compete in 8 technical tasks that are designed to test and maintain the robust solutions and to test them in scenarios related to Mars exploration. So, from these 8 main tasks, they are divided into 5 main categories. The first of which is traverse navigation. The rover should be able to autonomously navigate rugged and difficult terrain using onboard sensors as well as pre-placed landmarks. However, we can all imagine that on Mars, some districts might be tough to attain or the rover might get obstructed. And thus, our drone comes into play. So the target of the droning task is to supply aerial reconnaissance and information in zones where the rover cannot go. However, we do not just stop at movement. We also need to repair, as we imagine some things can go wrong on Mars. So what we have is a 6 degrees of freedom robotic arm. This will be controlling via either teleremote or in autonomous mode to be able to repair any control station or any control panel using buttons and switches. After this, we get to the science task. The science task pushes it even further. The target of the rover is also to analyze atmospheric samples as well as soil samples to make sure that the atmosphere is viable for human survivability. Finally, our drill is here to be able to drill depth more than 30 centimeters below the surface in order that we can be able to test and analyze what lies beneath our feet. So, let me now introduce you to the team, the amazing team behind such a project. A group of over 40 passionate students come together with a shared vision to create such a rover and drone. In this architecture, we are based on an engineering hierarchy. I serve as a project manager, accompanied by 3 systems engineers, each control one of the 3 key domains that we have: mechanical, software, and electronics. Beneath this systems layer lie all the subsystems. We have 8 subsystems, each managed by 1 or more team leader, expert in his or her special domain. Keeping this in mind, we get to the point that we all are waiting for. And together, this is the team turning vision into reality, 1 subsystem at a time, under shared mission. And now, after month on month of dedication, work, tiring days, and enthusiasm, it's time to reveal what we have done throughout the year. Please turn your attention to the big screen as we proudly unveil the rover and drone of 2025. Thanks a lot for the amazing enthusiasm. However, this year we not only prevail and we not only unveil the new rover and drone, we're also here to unveil something new, the newest addition in our navigation system, the OmniDrive. And by that, we have super control. We have all control in every terrain. We can move in any direction at any point in time under controlled circumstances, which gives us advantage on Martian terrain, or in our case, in Poland. So what happens behind these amazing unveilings? To ensure seamless coordination and work between 40+ member teams, 8 subsystems, and multiple team leaders, we need, of course, our 3 main system engineers. So for now, I proudly invite to the stage Ferraul Ibrahim, responsible of our mechanical system, Giovanni Ranieri, our software systems lead, and finally, Elliot Abramo, in charge of electronic systems. So now you've seen everything. However, to better understand what happens, let's take a closer look under the hood. At the ERC pole, what we do, we create and build 2 robotic systems. The first one that you just seen, it's Phoenix, a robotic rover that is capable of navigating using four-wheel independent steering and driving system. As well, it's equipped with a manipulator, 6 degrees of freedom robotic arm to have maintenance task. In addition to that, at the back we can see a drill, a bit of a shiny drill, that is capable to drilling 30 to 40 and even 50 centimeters deep below the surface. But we don't only stop at that. At the top, you can find Zephyr, our drone, in which it should be equipped with machine learning models to help autonomously navigate and to sustain information, area reconnaissance to the rover where it cannot get. Sorry for that. So, as I was saying, basically every year we can see the rover and drone as human beings or as beings in general. Every being is constructed of a body, nervous system, and a brain. And for that, we would like to start first by explaining our body's architecture and main enhancements with Ferraul.
Okay, thank you. As you have seen earlier, we work every year to improve our rover design. And this year's main issue we encountered concerns the vibrations. The rover tends to vibrate a lot, and that isn't something nice to have in a mechanical system. So let's get into the work achieved this year to address this issue. The rover vibrates a lot while driving over rough terrain because it is not equipped with a proper damping system. Every time it moves over rocks, these vibrations cause both mechanical and electrical issues. Screws tend to loosen, and even electrical connection can be weakened or even worse, disconnect. So to tackle this, we first measure the rover's vibrations to determine where the main vibrations were occurring. Once we have that, we choose to iterate into a new wheel design to mitigate the issue at its source.
So, however, we can always imagine that a body without anything else will not work. We need data transfer. We need neurons in a body. And for that, we have Elliot to explain our electronic architecture.
From the very beginning, our emphasis was very clear: global system cohesion. Every decision taken, every line of code written, every cable routed was done with one objective in mind: integration. The result? A system where each subsystem acts as an intelligent black box, self-contained, modular, and in lockstep with the control station. Now, this paradigm allows us to move in parallel, with the hardware and the software evolving side by side without stepping on each other. All subsystems stand alone, but move in parallel. This decoupled architecture doesn't only speed us up, it empowers us to innovate at every layer, at every stage. Now, it's not only about elegance, it's also about pragmatism. Each module in the rover is designed to be rapidly removed and unit tested, allowing our team to execute high-intensity stress tests, identify points of failure, and refine with surgical precision. Debugging becomes faster, testing becomes more intelligent, and progress becomes exponential. Now, we've also reimagined cable management, turning an afterthought into the basis of solidity, of stability. With this rover, each component stays in place, even under the most demanding of conditions. Minimal rotation with maximum reliability. And now, probably most importantly, we've embraced the ethos of plug and play. With this rover, you take a component, you plug it in, there is no step 3. Now, At the core of the rover is a single unified power source, a custom 8S 4P custom battery pack that's been rigorously field tested and proven under high-stress situations. For the first time, the battery never has to leave the rover. We've created a custom charging board, eMux, capable of delivering safe, in-place charging. It's easier, it's safer, it's cleaner, and it removes all handling errors. The rover becomes like an iPhone. You plug it in, and it's ready to roll. Now, beneath its sleek exterior beats an industrial-grade safety system. Picture a trinity of a 40 amps IEC-compliant circuit breaker, an automotive-rated relay, and a UL508 emergency stop. 3 layers, 1 mission: protect the rover. Now, just like everything else we do at Xplore, we don't just engineer for the solution, for the specifications. We engineer for another planet. Autonomous emergency shut-off achieved in under 2 milliseconds. The secondary isolation circuit decouples motor controls from core systems, allowing us to maintain clear and important access to all components at all times. And finally, an integration suppression hardware system protects electronic components from voltage spikes and electromagnetic interference. And to further harden all of the pipeline, we've introduced a pre-charge circuit, gently ramping up downstream capacitance, taming inrush current, and preserving hardware integrity. Now, this isn't just a safety system. It's a carefully orchestrated defense organism. Every place, everything is protected. Because on Mars, there are no second chances, and that is our objective. Power isn't just flowing through this rover. It's alive, it's intelligent, and it's ready for what comes next.
And yet, electronics are not only the main thing. However, because without intelligence, it's only wasted energy. So to explain more about the intelligence in the system and the brain behind every decision we have made and every decision that the rover and drone takes, I let Giovanni.
5 years of software development brings a lot of challenges. When many hands shape a project across the years, complexity tends to accumulate, systems become harder to understand, and code becomes harder to maintain. This is why this year we've focused on 2 things: maintainability and robustness. We want future members of the association to easily understand and improve the work that we deliver today. Our robustness starts with the software ecosystem. To manage all the software components, we use Docker, a well-known application that tries to remove compatibility issues when working with many libraries. Every subsystem will run in what we call a container, with applications, libraries, dependencies installed in it. And it's like a small package, and every package is isolated from the others. Last year, every Docker container were launched at once, whether we needed them or not. It worked, but it was inefficient. It meant longer startup times, more resource consumption, and less flexibility. This year, we've built a completely new layer of control directly into our control station, giving us dynamic and real-time control over what runs inside the rover. You may ask now, what is the control station actually? It's the web application that we use to control remotely the rover during the competition. To control these containers, we use a small web server that handles remote connections to any device inside the rover, giving us a way to start, stop, and monitor every container on the rover. This web application started last year, and we mainly improved the data monitoring and the autonomous control of the rover. Now, speaking of autonomy, our robotic arm benefits of a completely new pipeline of commands. More modular, easy to use. The idea has been to reduce the number of tools that we were using, and at the same time complexify our software architecture to have a deeper control of the robotic arm with ROS. In the end, we've connected 3 different worlds into one seamless experience. A beautiful control station where missions are designed and launched, We have a new decision and perception-making layer, allowing the rover to understand objects, compute their positions, and plan what to do next. And at the end, we have refined the implementation of the path planning framework that we use, called MoveIt, that turns these decisions into safe and efficient motions in 3D space. But that's not all. This year we've gone very deep, rewriting the very core of how the arm moves when manual control takes place. We've designed a full custom inverse kinematic engine, allowing us to move the gripper wherever we want. And with our new velocity control, every motion feels smoother and incredibly precise.
To ensure such smoothness, we also needed to work into the hardware. So here is the latest iteration of our robotic arm, where we focus into 4 main areas: ease of assembly, structural rigidity, backlash mitigation, and dynamic performance. One of the major focuses for this year's design was to improve manufacturability. With the exception of a single part, the entire arm cannot be manufactured in-house. This not only allowed us to operate into a tighter budget, but also provided some great opportunities for team members to engage into a fabrication-oriented design. Concerning the transmission, we opted for a sacroiliac drive as shown on the video. We have an 11:1 gear ratio at this stage, which allows us to have a higher torque while reducing the speed. We also worked on reducing the backlash, since it was a major problem we faced last year. By adjusting the diameter of the brass bushings, we were able to control the backlash and fine-tune it for each joint to keep it as low as possible. And finally, concerning the actuators, they have also seen an upgrade by selecting motors that are more appropriate to the arm operating point. We were able to increase speed by a factor from 3 to 10, while maintaining the same torque required for high dynamic motion.
Obviously, the rover has to localize itself. Our main tool for that is called a Kalman filter. It's an algorithm that combines past observations and noisy measurements to produce the best possible estimate of something that changes over time, like position. We use an extended version of it through sensor fusion with, for example, IMU data and wheels odometry. In this fusion, this year, we also have our front camera that uses a new visual inertial odometry, giving us an even better estimate of the rover's position. In a dynamic way, we also continuously map the environment around our rover using our LiDAR-based system. And it works with an obstacle detection layer. To better capture the LiDAR information, we use a new LiDAR mapping library, LiDAR inertial mapping, library called GLIM. And when the rover wants to move from point A to point B, in the end, we use a hybrid A-star planner completely designed inside the navigation stack of ROS. In the end, our autonomous navigation has been intensively tested through real-world applications, environments such as under unpredictable lighting, realistic terrains, and we use these trials to make major decision designs. Finally, to bring this new level of control, we are proud to introduce our 2 new compute units. They're 2 Jetson Orin NX modules. They're small, they're powerful, and they're energy efficient.
You have mentioned a lot of words, a lot of topics. However, can you elaborate what is ROS actually?
Yes, of course. ROS stands for Robot Operating System. It's the main set of tools that we use inside our software stack. Its main goal is to share data between software systems. The core idea is any piece of code running on the rover's network can communicate with the others if they both use ROS. And these pieces of code are called nodes. Our main node is the rover node. It acts as an orchestrator, meaning it receives and dispatches every command sent between 2 subsystems. So it acts as a central and security entity. Having every component using ROS is a key objective if we think on robustness and scalability. Actually, Only the avionics node is not integrated with ROS.
Indeed, in the past, the avionics pipeline was quite fragmented. Disparate modules, too many moving pieces, and a complexity that resisted global system cohesion. Which is why, this year, we're engineering a brand new next-generation avionics pipeline with our very own new custom board, which was purpose-built to host another custom ROS node natively on board. Now, with this system, every actuator, every system, every sensor on the rover will act as a first-class citizen in the rover's meshed network, streaming real-time data in a single unified communication pipeline. No more middleware layers, no more juggling. Just clean, deterministic control. Simplicity is not a constraint, it's an engineering principle. And in that simplicity, we found elegance, control, and resilience. The avionics forms the backbone of our science plan, streaming real-time data on both the rover's current state and surrounding environments. But scientific analysis also plays a key part in our mission here at Xplore, as our objective is to explore another planet after all. So each year, we create detailed geological maps of the Martian terrain we're trying to study, that we're trying to discover. And by identifying key features and key landmarks, we're trying to see how that terrain will evolve over millions of years on Mars. Our analysis is based on real-world scientific data, using studies that actually reflect the Martian terrain we're trying to study. And this year, it's the largest canyon in the solar system.
So, merging everything that we mentioned together, as well as working with the AI team, we can be able and can imagine things that even conventional robotics cannot do. Allow me to demonstrate. Phoenix, give us a turn. So, that's it for Phoenix. He's taken the time a lot. Now, we move on to Zephyr, our drone that we have forgotten for a bit. Every layer in Zephyr's architecture has undergone significant improvements. Let's start from the bottom up, taking at the bottom the landing mechanism, in which we have inspired from skis, creating it for a mixture between PETG and TPU. Ensuring robustness, we have the PETG, and then we have good shock absorption. The redesigning of the landing mechanism kept in mind the maintainability and the fast replacements in case of damage or other rough landings. Just on top of that, we find Zephyr's brain, a Raspberry Pi, that it will be doing the computations and it will be running machine learning models. Their goal and target is to detect different objects, locate them, locate itself, and help navigate autonomously from and back to the base needed, or in our case, for the ARC competition. At the topmost level, we are near completion our own flight control board. It's called Horatio. If you ask what this board is, the board is basically our sensor fusion. That's the board that takes all the sensor data, all the information, and computes the control signals, and then send them back to the actuators, send them back to the motors to effectively do the task. Thank you all for your attention and enthusiasm. I hope going through the European Rover Challenge, our team has shown you everything that motivates us and that pushes us forward. However, let me just give you a quick recap. We've talked a lot about a lot of things: rover, drones, Zephyr, ARM, drilling, and everything. However, the main thing to keep in mind is we work together. We work as a team. We learn, we fail, we learn, we move on, and then we succeed. And for that, we're trying to take everything that we learn inside the classrooms, inside the university walls, outside, and then to compete on the world level, in the international level, at the ARC Poland. So thank you so much for listening to us. Thank you so much. I hope we interested you enough. And now I'll leave the closing word to our dear president, Ugo Balducci.
Thanks. Thank you very much. You see this, an incredible job, and we're very proud of our new rover and drone. So that's great. But finally, we now reach the end of our presentation. So I hope you really liked it. We would first like to express our deepest gratitudes, and by starting with MAKE, which is the initiative we're part of. It's incredible because here at EPFL we can grow thanks to this framework. It gives us a lot of support, fundings. So I would like a big round of applause for Make. Thank you very much. Without any place to work, without any workshops, we wouldn't be able to do anything, to manufacture anything. So I would like to thank the spot, which has been very welcoming for the spaces that we can use, and all the different workshops at EPFL that enabled us to manufacture our piece. So a big round of applause for them too. Thank you to coaches. We have a lot of projects, and also we collaborate with academics. So multiple labs are part of the adventure. So I would like to give them a warm thanks. And what would be the association without our sponsors? They've been with us along the way from the start, pushing us forward, providing us with funds and technical support which was needed. So I would especially like to thank EPFL, Maxon, and APCO for their trusted support. They really deserve it. Thank you very much to all the sponsors. But what would be the association without our team? So, guys, I would like all of you to go on stage. Right now, let's go on stage. We're going to do a big picture. They really deserve the applause. These are the true heroes. From technical polls to our finance, to our communication, to our sponsoring, everyone has been working very hard for this. So a big round of applause for them. Before we finish, I would just like you to give us a little support and follow us on social medias, especially on LinkedIn and on Instagram. That will be very helpful. Thanks, guys. You will be able to follow all the news related to our competitions, latest events, so do not hesitate to add them to your feeds. What is coming next? So we have a few events until the end of this year, starting with our first competition in Switzerland right next week, the Rover Traff competition. Then we will have our second iteration of the Xplore Challenge at MED at EPFL the 24th of May. And finally, we'll end this year with the European Rover Challenge in end August. So if you want to have the updates, just follow us on social medias. And now, we've reached the end of the presentation. It's now time for refreshments and some food. So thank you very much for staying with us, and enjoy.